So good afternoon. Welcome to Introducing Kamal Proxy. My name's Kevin. I'm a programmer at 37 Signals, and Kamal Proxy is one of the things I've been working on there recently. So before I get started, I did want to say, if you've just watched Donald's talk, which is also about Kamal, don't worry. I'll be talking more about the proxy layer, not just about Kamal, so there might be a wee bit of overlap, but hopefully it's not going to be like a Groundhog Day kind of situation for you. But at the same time, if you didn't watch Donald's talk, also don't worry, because I'm not going to expect you to have a lot of Kamal knowledge going into this. In fact, all the things that you'll need to know about Kamal for this to make sense, we can fit on one slide, which we'll do in a second, and then we'll all kind of be on the same page from there. Okay, so just a quick look at what we'll cover in this talk. Pardon me. We'll just start by going through what Kamal Proxy is, talk about why we decided to build it, how it works, and what it's for. And then the bulk of the talk will be to take a wee tour through some of the new features that we've added in the proxy. So there's 9 features that are kind of arranged kind of roughly into a few different categories. There's some things there to make it easier to set up your deployments in a way that it'll feel kind of production ready. I know that's a bit of a vague term. I think it'll get a bit clearer when we get into the details there. But some of the features are for that. There's some features there to improve the performance of your apps, so they'll perform better in production. And then lastly, some features that are there to help manage your apps once they're in production, make it easier to do the sorts of tasks that sometimes come up when you've got an app running. And then at the end, we'll just take a quick look at some of the things that might be coming next to Kamal Proxy after that. So, as promised, the one slide or one-pager guide to what Kamal is. The main thing is it's a tool for deploying apps. So if you built an app, probably in Rails, and you want to deploy it to production, run it on some servers so that people can use it, Kamal's there to help you do that. It's Docker-based, so it works by building a container image for your app, shipping that out to your servers, and then running the container image on your servers. And then, importantly, for the purposes of this talk, it supports what we call Gapless deployments. Donald may have mentioned this a wee bit. What we mean by Gapless deployments is if you have a version of your app running in production and you deploy an updated version of it, then as we're transitioning from the old version to the new version, there should be no gaps in service. There should be no points where your app's unavailable because the new version is booting, or no requests that were errored or dropped as a result of the deploy happening. It has to be kind of a seamless transition from one to the other. And as we'll see in a minute, that's where the proxy layer comes in. And then lastly, I want to acknowledge that despite me squeezing this in one slide, Kamal does a whole bunch of other things too. I'm totally underselling it by trying to put it on one slide, but it's just that those other parts aren't things you need to know in order to talk about a proxy, which is what I want to talk about. Okay, so the gapless deployments, as I mentioned, the way they work in Kamal is that when you have a version of your app to run and you've got the app container built, we don't run it on its own on a server. We run it alongside or behind the little proxy layer. And then all the traffic that's going to come into your app comes through the proxy before it gets to the app. And that proxy gives us a stable endpoint so that we can then change things behind that to get onto new versions and things without affecting where people access their app, if you see what I mean. So the process of a deploy is basically boot up a new container with a new version of your app, ask the proxy to switch traffic from one to the other, and then you can remove the old version, and then it's done. And so this proxy here, that's what Kamal Proxy is. In Kamal 1, it was a third-party proxy called Traffic that we used to use, and so Kamal Proxy is replacing that. Which leads to probably the obvious question of why build a new proxy if we had one that was already working. And so there's really 2 reasons for this. The first one is just an iterative improvement. It's just about trying to do a better job of making these gapless deployments work. And so although they work in Kamal 1, it was quite complicated to get them to work well. The Kamal code has to handle quite a lot of complicated interactions between itself and the proxy to make sure that the transition from one version to another happens sort of seamlessly and doesn't do anything wrong. We also found that there are some kind of edge cases and sharp edges with it, where you could occasionally a bit of misconfiguration might lead to traffic not routing where it should or something like that. And so as we worked with that setup, we started to realize that if we would just build our own proxy that's purpose designed to handle this kind of traffic switch that we need from it, which is really the only thing we were asking it to do, we could really simplify how this works. We could make it a lot more robust, and we could also make it a little bit faster in the process because the proxy would have more knowledge of like the detail of the requests that were going on at any one point in time. We can use that to speed the process up. So that was our first reason for building a new proxy. And on its own, it seemed like a fairly compelling reason. But there's a second reason for it too. And the second reason came up actually while working on a different project. So if I kind of rewind about a year or so ago, I was working on the team that at 37 Signals that was looking at building a new line of products called Once. The first of which was Once Campfire, which you probably heard of. If you've used the Rails word Campfire, it's one of these. And the idea behind the Once products is that rather than as an alternative to SaaS software, we could instead offer products that we would build and sell you as like a packaged piece of software that you can run yourself on your own server, not pay any ongoing software costs for it, and you can kind of run it wherever and however you want. So it's a bit of a different model to try. But for that idea to be sort of viable and appealing, it has to be really easy. Like you can't get a piece of software and then have a big long list of things you're going to need to do in order to run it in production. It has to be more like you buy it, you boot it, you put it on the internet, and everything's working great. So that meant we had to figure out how to get enough performance out of kind of modest hardware so you didn't have to spend a lot on hosting, but also how to build in answers to some of the things you might normally have done outside of the app itself. So things like setting up SSL certificates or figuring out how to make sure your static files were served quickly and that kind of thing, those would all have to be built in. So the way we ended up solving that for Campfire was through this library Thruster, which is really just a little proxy. It runs inside the container with your app next to the Rails process, and it provides some of those parts that would otherwise have been missing. Like if you just take a Rails app running Puma and stick that on the internet, it'll work reasonably well, but you'll be missing some things that you would want for it to be to feel fully sort of production ready. So Thruster fills in those little middle parts, or missing parts, sorry. So that turned out to work pretty well for the Once product. So Campfire works like this. You can just boot the container, stick it on the internet, and get good performance and so on. And so this kind of started making us think about the second reason for writing our own replacement proxy, which was, if this is working well for apps like Campfire, we should make sure and share this in a way that will work well for any Rails app that people build. So as soon as you build your app and deploy it, you should get that same experience of you just boot your app on the internet and everything works the way it should. So that led to the second reason, which, as I say, was really about making it easier not just to have your app run, but to have your app run really well. And so in Rails 8, by default, this is the kind of setup you get now where if you make a new app, deploy it with Kamal, you'll have Kamal Proxy running kind of in front of your app. You'll have Thruster running in the container next to Rails. And Kamal Proxy and Thruster will work together to take care of all those sort of missing parts that I mentioned earlier. And so I realize I'm still being a bit vague about what the missing parts are, but we'll get to that in a second. And I just wanted to also mention that the more we talked about this reason too, the more we realized that there's a further version of this that's more of a sort of lofty goal, which was not only can we make it easier to get your apps working with the things that they need, but we could also look around to find like what were the other convenient parts that you might have been getting if you hosted your app somewhere else, if you used like a Heroku or some kind of platform as a service, managed environment kind of thing. If we keep spotting the convenient things in these other environments and bring those into the proxy as well, we should be able to make it so that self-hosting your apps becomes like a better alternative. It should be easier to set up, or it could be more convenient to run with. It could be cheaper because you don't have to pay anybody else. There's no overhead. You wouldn't have the same kind of lock-in to a particular platform because it's just everything that you're running just runs on a basic Linux server, and all of the conveniences are software that's open source that are in your project and you can take wherever. So we have this lofty goal too. Where we've reached today, I think, is we have the answers for reasons 1 and 2 today. The lofty goal is kind of a thing that we're working towards, but there's more to do there. So in terms of specifically how Kamal Proxy improves Gapless deployment, so how we solved the reason 1 there, really, there's a few things that are going on, but it really boils down to the way that we made it so that Kamal can interact with Kamal Proxy. And so with traffic, we were working with it with a bit more of a kind of lower level, and there was a lot of coordination that had to happen between Kamal and Kamal Proxy to make things work. The way we've redesigned that with Kamal Proxy is by giving it commands that you can use to instruct it to do things. So Kamal Proxy runs, it sort of has 2 parts. It runs as a proxy service that's kind of a long-lived process that routes traffic as it needs to. But then there's also a set of CLI commands that come with it that you can run to tell it to do things. So one of the main ones is the Kamal Proxy deploy command. So when Kamal needs to initiate one of these traffic switches that we saw in the diagram before, instead of having to do a lot of back and forth interaction, it can just run this one command, specify the name of the app, and this target flag is the host name of the container that we want to route traffic to. And when it does that, Kamal Proxy can go through the steps necessary to do the whole switch. So it'll wait for that container to be healthy by doing health checks on it. When it's healthy, it can start routing any new requests that come into the container. But while that happens, there's probably some in-flight requests on the old one, so it can watch those and wait for them to complete, and then in the instant that the last one of those is finished, it can return success back to Kamal, so Kamal knows that it can, at that point, destroy the old container and kind of move on with its other tasks. There's a lot more kind of flexibility in this deploy command. There's other flags and so on that you can pass, but really what it boils down to is having this model where we can just instruct the proxy to do something and let it do it, and there's not any kind of back and forth trying to coordinate with it. So that was the reason 1 for building the proxy. Reason 2 is really about the features that I wanted to go through and quickly show you. And so these are the things that we've tried to add to just kind of make deployments work a bit better. Arranged in the categories that I mentioned at the start, there's 9 things that we'll look at today. Some of them we'll go through pretty fast. There's a couple at the end that we'll look at in a wee bit more detail, so I'll just get started going through these. In terms of easy production deployments, you'll have seen some of this with David's keynote this morning, but we've made it really easy to set up or to deploy multiple apps onto one server. This was kind of surprisingly fiddly to do with Kamal 1 and with some other deployment tools, because all of your apps will want to fight for the same ports. So in Kamal Proxy, we've given it the ability to do host-based routing. And so when you deploy an app, you could just tell it the host name that your app wants to serve traffic on, and then a single instance of the proxy can serve multiple apps and route the request as necessary to the right one based on their host name. We added automatic HTTPS because that's something that almost everybody's going to want. And that's kind of easy to do automatically with Let's Encrypt. So if your app wants HTTPS, you just have to select that you want it, and that will get taken care of automatically. And we also added buffering of requests and responses by default. So having this on and built in by default means that the Rails process is kind of isolated to some degree from clients that might misbehave in some way. So clients that are really slow to send a request or to read a response could tie up a Rails worker for a long time, or a client that sends an oversized request that your app isn't capable of handling could cause problems. So we have this buffering layer that's on by default that will fully buffer the requests on the way in and then the responses on the way out. And you can set a size limit if you want to cap the sizes of your requests. So those are kind of just there and kind of automatic to make things a bit easier. The next category are things that are there for performance reasons. HTTP2 is just kind of the way that it's on by default. The proxy will serve all its traffic over HTTP2 as opposed to 1.1, which is what you would get running Puma on its own. That makes a huge difference if you have an app that has a lot of files to download, like an app that has many assets or something. HTTP2 is We're like a lot faster for that. And then the other couple of performance improvements we added are really about making it faster to send content from your app back to clients. And so we'll look at those in just a wee bit more detail. They're the HTTP caching and this XSend file support. So for HTTP caching, it's useful because most apps have a ton of things that cache really well. So all of your static files, like your assets, CSS, images, and everything, those tend to cache really well. You might have also some public pages that don't change much that you could cache. And so the goal here is to offload serving any of that from Rails and have it served instead by something that's a bit more dedicated for that and can do it in a more lightweight way and do it faster. So in Rails 8, by default, all asset files that it serves will have cache controls headers set already to say that they're cacheable. And Thruster running in your container next to the app maintains an in-memory cache of all of the cacheable responses that it sees. And so without having to do anything to set it up, out of the box, asset serving will just be fast in this environment because whenever you deploy a version of your app, after the first couple of requests, assets will have been sort of requested and pulled into the cache and then served directly from the cache from that point on. But obviously, it's not just for assets. If you want to use it on other responses, it's just a case of setting the cache control headers that you want. And you can use the normal Rails helpers for that. So if you set something to say expires in 7 days, then Thruster can cache that for 7 days, and your app doesn't have to keep serving it. So it's useful for things like a login page that isn't changing per user. In terms of how much difference this makes, I did just to get a data point, I took some measurements running the Campfire container on kind of a low-end DigitalOcean droplet, one of the sort of cheaper sizes. And on that, dynamic pages served by Rails, we're going at about 160 requests a second. But if I take the same page and mark it cacheable, then Thruster can do that at 8,200 requests a second. So it's like a 50 times speed up to get once you get something in the cache. And obviously, that's not a very fair comparison. It's not to say one's faster than the other. They're just different things, and there's a reason that we use dynamic, that we want to have dynamic responses. That's why we're building Rails apps and not static websites. But again, I think the point here is just if we identify the parts that don't need to be dynamic and let the cache serve them, then the capacity that you do have for dynamic requests on that particular instance goes a lot further. XSend file is somewhat related in that it's also about being able to send content back more quickly. XSend file is a convention where if you have a controller action that needs to respond with the contents of a file, so if maybe you have an app that serves up big video files or something like that people can download, rather than Rails have to send back all of the content for the file, it can just respond with a path name, the location on the disk where the file is, and then Thruster can pick up on that and take over the work of actually serving the file. This is something you don't really need to think about, or there's nothing to do to set it up. It's supported, and it'll kind of kick in the situations where it can. Usefully, one of those situations is active storage. So if you're using active storage to store content on a file system that the container can access, your app container, then the XSend file support means that serving those files will be handled outside of Rails for you. And so the files will be served faster, but also it'll free up more time from your Rails workers. Okay, and so then the last category of things I wanted to look at were features that are there to make it easier to manage apps once they're in production or to do things that would be useful. These are the parts that I think are more interesting, and it's where we can, I think, start to see how having a custom proxy lets us build some more conveniences in that we wouldn't normally have. So the first of these is having an easy way to put up a maintenance page. It's pretty common if you're running an app in production that from time to time you'll have to take it down for a little while to do something, like to do some kind of upgrade or change some infrastructure or something. And you'll want to put up a maintenance page to let people know what you're doing. So we made a proxy command for it. You can call Kamal Proxy stop with the name of your app, and the proxy will immediately just start serving a temporarily unavailable page for you to show that your app's down. It's kind of a generic page because obviously we don't know anything about your app or the reason that you're stopping it. But you do have the option to pass in a message when you call this, and whatever you pass as the message will be displayed on that page. So like in this example, you could put a note to say when your scheduled maintenance is going to be done. If you want to change these more, you can actually supply your own HTML templates for the proxy to use instead. So you can brand these to suit your app. And that's on a per app basis. So if you're using the feature to deploy multiple apps on the same server, you can give them all their own sets of pages and have them look like your app. And then when you're done with your maintenance, there's a resume command, which is the opposite of stop. It just brings your app back into service. The second feature in this category is request pausing. This is kind of related because it's also about times when you need to do a bit of maintenance, but it's for the cases where the maintenance is not going to take a long time. So an example of this might be that you might have to reboot a database. Maybe you've applied a security patch or something, but you have to restart like a Postgres server or something to pick up those changes. You can't just do that live. I mean, you could do that live, but people will see errors from your app for the time where Rails can't connect to the database because it's restarting. So an alternative to having a downtime for this is if you don't think it's going to take very long, you can ask the proxy to just hold on to all the requests that are coming in and sort of let them queue up until your app's ready for them, and then it kind of finishes playing them through. So the sequence of commands would be something along the lines of this. So if I was going to restart a Postgres database, I might use something like this pgctl restart command. So if I do a proxy pause first, then my restart, and then a resume, then in the time between the pause and the resume, there will be no request actually flowing into my app. They'll just be sort of kind of queued up for a moment and then played through. This one I find a wee bit hard to describe how it would look, so I've got a little video to show what it looks like from someone using an app. So this window on the right is just a Campfire instance running, which is deployed behind Kamal Proxy. It's also an excuse for me to be able to show a picture of my cat in the talk. But you can see it's working normally there, but if I hop over to this terminal and pause the service at the proxy level, then the next request is, you'll see the loading bar because it hasn't been able to go through yet, but as soon as I then resume the service, the request finishes. So no one saw an error, but we had a few seconds there where we could do stuff behind the scenes where the app was kind of down. And then the last feature that I wanted to talk about is Rollout. So Rollout, the idea behind Rollout is you can deploy an alternate version of your app alongside the main version, and then you can use some kind of traffic split to send just a certain portion of your traffic into this alternate version, this Rollout version, we call it. So it's useful for things like a canary deployment, or if you want to try out some kind of like a library upgrade or something, and you want to see what effect it's going to have, you could deploy it to a small portion of your users, or maybe just to your own account or something like that, before you roll it out more widely. It works by having the proxy identify the requests that come in to know who they belong to, and then to use whatever traffic split rule you've told it to decide where to send those requests on. And so for this to work, it does need a way to know which request, it needs a way to know who each request belongs to. So the way you do that is just have your app set a cookie with a value that makes sense for your app. Whatever you put in there, that's sort of the unit that your rollout can be controlled by, if you see what I mean. So if your app has a notion of accounts, then account ID is probably a good thing to put in there, because then you can say which percentage of accounts should go to rollout or which specific accounts. Other values that would make sense in there might be things like user IDs or geographical regions or something like that. And so as I mentioned, once it's set, you can control the split, either a percentage, in which case they're sort of randomly allocated. If you say 5% of accounts, then it's going to be a consistent random 5% of all the accounts. Or you can use specific ones. We use this approach a lot at 37 Signals, actually with a different mechanism. We use it a lot on Basecamp, which doesn't use Kamal Proxy. It has its own rollout implementation that predates this, and is kind of where the inspiration for this feature came from. But we use it a lot to do things like if we want to change the Ruby version that we're running against. You don't want to just kind of change that and deploy it to everybody without having a better look at the effect it's going to have. And so a rollout feature lets us make these kind of changes in a more controlled manner before we do a full rollout. And so like the other features, this is also driven by a set of proxy commands. There's a subcommand called rollout. So you can call things like Kamal Proxy rollout deploy rather than Kamal Proxy deploy. The rollout deploy version is a way to register the container that should get rollout traffic, but it doesn't yet send any traffic to it. For that, you've got Kamal Proxy rollout set, which is where you can give it something like, in this example, %15 just means send 15% of the accounts. If I'm using account as my cookie value, if we send 15% of accounts into rollout and the other 85 go to the regular container. If you want to isolate specific accounts, you could use a list form. So you could say that account IDs 7, 29, and 30 are the only ones getting rollout and nobody else is. And then when you're done with your rollout experiment, you can just call rollout stop, and that resets everything. All your traffic goes back to your main container, and you're kind of back where you started. So that's all the features that I wanted to go through today. These all exist now at the proxy level, and some of them are things that are built in and just work. So things like X send file or the request response buffering, they're just features that happen. You don't have to think about them. Some of them are things that you access through Kamal. So things like multiple apps per server are there because they're present in the Kamal config. That's who use those. And then a couple of the ones at the end, at the moment, only exist in the proxy. We've not yet surfaced them in Kamal. So if you wanted to use them now, you can. You would just be sending the Kamal proxy commands directly. But they are things that soon we will have them at the Kamal level. So Kamal will let you kind of do all those things in one place. So those are all the features I wanted to look at. And then, as I say, the one thing I wanted to mention at the end was what other things we're starting to look at to add next to it. I think the goal here is mainly will be to continue to look for things that would be super convenient to have, especially if there were things you would have gotten in another environment and would make you feel like self-hosting would be a step backwards. I think spotting those types of things and seeing if we can build them in is kind of the mission for the next wee while. Specifically, two things that we've started to look at now that may come next, I think. One is load balancing. So right now, if you have an app that runs across many hosts, Kamal does a great job of deploying across those hosts, but it doesn't have an answer for how you would load balance your traffic amongst them. You sort of bring your own load balancer in that situation. But I think we can do this probably quite effectively at the proxy level. So the proxy can serve as a load balancer between hosts. That would give us the ability to, like, we could make it very easy for you to have a new Kamal deployment where you have multiple hosts in there, you deploy it, and you're provided with everything from the ingestion point with its SSL certificates and the load balancing and then all the deployments and all the hosts. Like, we can do kind of the whole picture there, which I think would be kind of neat. So that's definitely something we're looking at. And then the other one is WebSocket acceleration. We've got some ideas there about, since the traffic is already flowing through a proxy before it gets to your app, I think there's some cool things we could do by intercepting that for WebSocket traffic. So if you have an app that does a lot of real-time activity, a lot of action cable type stuff, we can probably make that faster as well, in the same way that we've been looking for ways to make the regular HTTP content faster. Cool. So that's everything I want to go through today. Thanks for listening. If you want to talk about proxies, please send me an email. Thanks.